Chemical weathering. So chemical weathering is the process by which rocks and minerals undergo changes in their composition and then break down into smaller pieces. This is caused by water, oxygen, carbon dioxide, and acid precipitation. So this causes some substances to dissolve and then some new minerals to form as well. One example is iron combining with oxygen to form iron oxides. Iron oxides such as hematite or magnetite. Those are iron oxides. And again, this is just iron reacts with oxygen to produce these iron oxides. So factors affecting chemical weathering. So the composition of a rock determines the effects of chemical weathering. So calcite or calcium carbonate decomposes in acidic water. Limestone and marble are made almost entirely of calcite, so any acid precipitation or water that ends up in the soil that picks up organic acids and stuff becomes acidic, and then that acidic water can break down calcite or calcium carbonate. Temperature also affects chemical weathering because it influences the rate at which chemical reactions occur. So this is basically in the lab or anywhere. If you increase the temperature, you increase the reaction rate. So the reaction rate doubles with each 10 degrees Celsius increase in temperature. So the warmer it is, the faster these reactions will occur. So water's role in chemical weathering. So water can dissolve many kinds of minerals and rocks. Water also serves as a medium in which reactions can occur, so it allows different compounds to come into contact with each other. So it may dissolve a mineral in one place and then that reacts with a rock somewhere else. Water can also react directly with minerals in a chemical reaction. So large molecules of the mineral can break down into smaller molecules. Many silicate minerals decompose and transform this way. So for example, potassium feldspar decomposes into kaolinite, which is a fine-grained clay mineral common in soils. So again, this is minerals reacting directly with the water to break down into smaller molecules. So oxygen's role in chemical weathering. So oxygen is an important element in chemical weathering. The chemical reaction of oxygen with other substances is called oxidation. So oxidation is when oxygen reacts with other things. Approximately 21% of Earth's atmosphere is oxygen gas. So oxygen commonly reacts with metals to produce metal oxides. Iron is a common metal that oxidizes. We've seen this with rust and things like that. And then a mineral that contains the oxidized form of iron is hematite. So you have iron that oxidizes and produces hematite. Carbon dioxide's role in chemical weathering. So carbon dioxide combines with water in the atmosphere to form a weak acid called carbonic acid. Therefore, natural precipitation is slightly acidic with a pH of about 5.6. 7 is neutral as far as acid goes in the pH scale. So 7 is neutral. That's pure water. Lower numbers are acidic, so 5.6 would be acidic. 1 would be the most acidic, up to 14, which would be the most basic. Okay. Precipitation includes things like rain, snow, sleet, and fog. This is acidic enough to dissolve certain rocks such as limestone. So even just natural precipitation is acidic enough to dissolve limestone. Decaying organic matter in the soil produces high levels of carbon dioxide. And then when precipitation combines with carbon dioxide in the soil, carbonic acid becomes stronger. There are also organic acids that are in the soil from decaying organic matter. Caverns can be produced after many years of carbonic acid dissolving limestone. The effects of acid precipitation. So acid precipitation occurs when sulfur dioxide, carbon dioxide, and nitrogen oxides combine with water in the atmosphere. These produce sulfuric acid, carbonic acid, and nitric acid, respectively. So, sulfur dioxide reacting with water in the atmosphere produces sulfuric acid, for example. Nitrogen oxides react with water in the atmosphere to produce nitric acid. Sulfur dioxide and carbon dioxide are primarily the products of burning fossil fuels. Nitrogen oxides come mostly from motor vehicle exhausts. Nitrogen is actually very common in the atmosphere. It's like 78% of the atmosphere. And in the engines of most vehicles, that will react with oxygen and produce these nitrogen oxides. Acid precipitation has a pH lower than 5.6, because remember 5.6 was sort of our natural precipitation pH. So anything less than that is considered acid precipitation. Many plant and animal populations cannot survive even slight changes in acidity. So most things are very sensitive to changes in pH. This is a serious issue in New York, West Virginia, and much of Pennsylvania. And this is kind of what it looks like. A lot of forested areas, acid precipitation will basically start to kill off a lot of trees, and you'll end up with a lot of areas that just look dead like this.